what is a drone? From these two images, you can see there is a white drone and the black one. Someone will say the white one is look like one aircraft and the black one is the is a drone. But in reality, both are drones because drone is just a robot which is dynamically operated via remote. There is no human person on board on it. That's why it is called a drone, which is the subcategory of UAV, which means unmanned aerial vehicle. Means no man is present, which you will see in the next slide. So introduction to the drone. Okay, section 1. So here we see the terms like drone, UAV, and UAS. So what are those? So UAV stands for unmanned aerial vehicle. So there is no human interaction here. UAS, unmanned aerial system. So it is the system of the entire drone setup, which will include like ground control station, remote, pilot, aircraft vehicle, everything. And drone is just a common term, which is defined as a vehicle. This a quadcopter, hexacopter, this only. And UAV and UAS are just a technical terminologies of this entire system. Okay. Then, so what we'll think like if it is unmanned, then it is uncontrolled, but it is not. Since here there is no human inside, but it is controlled by its onboard sensors. There are multiple sensors present in it, which continuously measure the actual positions, angles, everything for the drone location, and then send the data to the drone to control by itself. And even here the human is just need to require some basic data, like if I want to move forward, backward, left, right, up and down, this basic data. But drone will perform all the calculation, everything in a controlled manner. Then aircraft versus drone. So you have probably seen some drones as well as the aircraft like aeroplane, but what's the difference between them? So in drone there is no pilot on board, that's why it is called UAV. And but for the aircraft there is a pilot on board. The drone can hover at a specific position, but the aircraft can't. It needs the runway to take off and land, but the drone can do vertical takeoff and land as well. The drone is always smaller in size and has a slower speed, but aircraft is too much bigger and even way faster than the drone. So these are some basic difference. Then let's see how many types of drones are present. I mean, mostly like we can consider the fixed wing. So there is just a fixed wing. There is no rotor on side it. Then is a single rotor, which is a kind of helicopter, you can say. Then we have the quadcopter, which is generally used in the every field like agriculture, surveillance, monitoring, rescue operation. Everywhere mostly the quadcopter is used. Then we have the hexacopter as well. When let's say if we want a very high payload capacity, like in agriculture sector, that time we go towards hexacopter. Also we have the tricopter. So these are the different types of drones which are present. Then there is one interesting category which is hybrid drones. So actually it is the combination of the fixed drone as well as the quadcopter drone. Here you can see there are the fixed wing as well as the rotatory wing. And because of this feature, this drone can hover at the specific position as well as it can be glide. So it can perform the vertical takeoff and landing. That's why this drone is called VTOL drone. With this, the help of this drone, we can get a maximum flight time as compared to the normal drone. That's why it is widely used in the new era of drones. Now, here we can see the drones of the India, which our Indian companies developed. Here you can see like DRDO Abhyas, DRDO Ghatak, DRDO Laksh, Nagastra, DRDO Bharat, DRDO Imperial Eagle, DRDO Rustam, Hiron. So these are the drones which is built in India. So now let's see what are the applications of the drone. So let's say we have developed the drone, but what are their applications? So the very first thing, like agriculture for fertilizer, I mean to spray on the crop, we can use the drones. For the defense application, we can use the drone. Then for the construction work, some search and rescue missions, some inspection like power line inspection or thermal inspection. For inventory management, we can utilize the drone. For the delivery purpose, as we all know, like different kind of delivery partners wanted to shift to the drone delivery so that they can provide the faster delivery. And the most interesting thing everyone interested to know, which is the drone show, where thousands of drones communicating with each other and draw a pattern into the air with the help of the light, and we can see the visuals. Now let's move toward the section 2, which is what's the physics behind the drones, how the drones fly, what. So this will look here. So core principle of drone flight. Everybody knows about the Newton's third law of motion, and what it is. For every action, there is an equal and opposite reaction. So let's say if drone has to fly, there is a force. The drone is supposed to be applied to the ground. If the drone applying the force to the ground, then definitely ground will oppose this force. And this is why the drone lifts from the ground. And to generate this lift, the propellers are in the scenario. So when the propeller rotates, it generates the air which pushes downside, and the ground force pushing the drone up. So this is how the drone lifts the ground. But now at what speed the propeller is going to move the upward? I mean, what should be the speed of the propeller so the drone can lift the ground? How we will decide this? So for that, the condition is the lift of the, I mean, the thrust of the drone, which is the lift, it must be greater than equal to weight of the drone. The drone will only lift the ground when the weight thrust is greater than the weight. So there are two forces acting right now, which is weight at the downside and the lift force at the upside. When the lift force is greater than wind, then definitely drone will going to be lift up and ready to fly. Now, and just adjusting the speed of the different propeller, we can move the drone at any sides. Then, four important elements of the drone flying. So, propulsion force, which is also kind of thrust, drag, weight, and lift. So actually, these are the four major forces which are acting on a moving drone. And these forces like thrust, drag, weight, lift, these are acting on the drone at every single time at takeoff, landing, hovering, forward movement, backward, in any direction. And how it works, here we will see. So elements of drone flying. So let's say I want to hover the drone at a specific height. So what I have to do? So at that time, what the forces will act? At the ground, there is a gravity force, which is mg. Then if I want to lift the drone, move up the drone, then I have to generate the lift force. Okay. And as we know, the drag force will always oppose the moment of the drone. So let's say if the drone is moving upward, then drag force will definitely act opposite to it. So now there are two forces at the bottom side, which is gravity as well as the drag. And the two forces are the upside, which are those, one is the lift force and second is the thrust force, which is propulsion force. So this is how the four forces are acting when we do the takeoff. But what if when we are moving forward or backward, then what should be the direction of these forces? So first of all, the gravity force will always act to the bottom only, as we know. Then second is the lift force. Lift force is always straight at the top. Okay. But now the thrust and drag, their position will be changed. Since the drone is moving forward, then drag force will definitely oppose it. So the drag force will be backside. But the propulsion force, which is thrust, it will be in the front side. So here you can see whenever we move the drone, the propulsion force and the drag force always changes. So this is the physics which is used to move a drone in the air. Now, moments that control orientation and direction. So drone is a 6 degree of freedom device. Here the drone can do roll, pitch, and yaw. And what are these terminologies? The roll stands for when we move the drone left or right. Let's say you place your drone in your hand and you want to move the drone left and right. That is called roll movement. And if you want to move the drone front and backward, then that will be called pitch movement. And when you move the drone at the Z axis, then it will be called yaw movement. So these are the three essential movements which control the drone in the air. Now, torque control. So here you can see at the forearms, there are four motors attached with four propellers. And the speed, position, moment, everything is controlled by these propellers. So we have to decide how we have to actually control this propeller so that we can achieve our goal. So let's say if I want to move the forward, so what I have to do? I have to just increase the speed of the motor from the back side. And similarly, if I want to go right side, then I will speed up the motor from the two left side. And there is one interesting thing regarding the yaw moment. Okay, so for doing the yaw moment, we have to increase the speed of the opposite motor, not the adjustant. And one more important thing, there is in the drone, there are two clockwise motor and two anti-clockwise motor. And you're surprising like why this is? Why not all four are clockwise or not four are anti-clockwise? Because if all are clockwise, then what happen? If the all motors running at the same direction, then according to the Newton's law of motion, the drone body will try to rotate in the opposite side. Then drone will be not stable at the specific point. That's why the two motors rotate opposite, which cancel out this force and the drone flies stably. So this is totally about the torque control. Now, so till now, we have just seen some basics of the drone and some physics behind it. Now, let's see the section 3, which is the drone building. Okay. So here are some basic parts of the drone. So when we look at the drone, the very first thing we see is a frame. Frame is just a mechanical body in which we place our all the electronic component like motors, battery, propellers, ESC, or everything. Here we have to mount it and connect it to each other. Then the second thing is the motor. What is this is generally in drones, BLDC motors are used, which are brushless DC motor, because these motors are very reliable, very high speed motors and generate a good amount of thrust for the drone to take off and fly. Then the third thing, the propeller. Propeller we need because propellers are the only thing which is generating the thrust by which the drone is getting lifted. And the propeller size we can decide based on the frame size we want. Here you can see some notations provided like 8045 propellers, 1045 propellers, 6030 propellers. So what does it mean? 8045. So 80 here is the 8-inch diameter of the propeller, and 45 means 4.5 mm, 4.5 pitch, 4.5-inch pitch of the propeller. So this is about the notation. Then next part is electronic speed controller, which is known as ESC. So we need ESC in the drone to control the speed of the motor, because these are the very high voltage motor. We cannot directly control it with the main controller. That's why we need the ESC, which will take the PWM signal from the flight controller, then generate the output signal, which is fed to the motors. Then we have the battery. Battery is the very essential part of the drone because it is responsible to deliver the power to each and every component of the drone, like flight controller, all the electronics, sensor, motors, everything. Then we have the power distribution board. The role of the power distribution board is to provide the power, distributed power to the entire drone. Let's say because motors want some different voltage, some sensor wants some different voltage, flight controller wants some different voltage at a different time. So this is the power distribution work to allocate the power to this particular component. Then we have the flight controller. The flight controller is the brain of the drone because it contains the sensors, multiple sensors like accelerometer, gyroscope, magnetometer, barometer, and it has the multiple ports and the very high-end microcontroller, which is continuously calculating the thousands of calculation per second. And the output is directly fed to the ESC, which control the actuator, which is a motor. Then we have the transmitter and receiver. Why we need the transmitter receiver? Because drone always fly wirelessly. We cannot use a simply wire here to fly. So that's why the transmitter you use, by which the pilot can send the signal from the ground to the drone. And this receiver will mount on the drone, which will receive the signals, and drone will fly according to the pilot inputs. Then we have the part telemetry. What is telemetry? So let's say you want to know what is the height of my drone, what is the battery percentage remaining, and other data like what is the position. So how you know that? So that's why the telemetry is used, which transmitting the drone data continuously from drone to the ground station. It is full duplex communication from the ground, as well as we can send the data to the drone, and drone also send the data to the ground station. Now here are some basic tools which is required for assembling any drone. Like the very first thing, like Velcro, which is just to tie a battery on the frame. Then we have the zip ties. Zip ties are really used for like mounting the ESCs or any wires or any congestion place. Then some electrical tape to isolate the circuits, and sure multimeter to measure the voltage, because we have to be provide a specific voltage to the specific component, because let's say motor wants 12 volt but flight controller want 5 volt. So before feeding this voltage, you must measure this voltage with the multimeter so that you don't damage any component. Then the very must thing is soldering iron and solder station, so that you can solder all the components onto the frame and make the drone ready. So this is how the assembled drone look like. Here you can see whatever the components we have studied, everything is present here. Very first thing you can see directly, the frame. Then the motors, 4 motors present on it, the 4 tri-blade propellers. There is a flight controller as well here, the cube, orange cube written here. There is a battery, power distribution board, GPS, receiver, ESC, telemetry, and this radio transmitter. Combining this all setup will make the drone fly. Okay. No, still now we have just discussed about some very basic intro, how to build it. But now let's see how the drones actually fly. Okay, so this is about the section 4. Now, as I told, like flight controller is the brain of the drone, which run the entire control system, which is flight controller system. And how it works, because it has the multiple sensor, integrated sensor, as I said, accelerometer, gyroscope, barometer, magnetometer, and also additionally we can attach the sensors like GPS, airflow sensor, radar sensor, any if you want to make the drone more reliable. And so this kind of sensor can be added. Okay, so this flight controller system generally mount at the center of the drone because it has to measure all the access properly. We cannot mount this controller at any place of the drone. Here from the images you can see the controller is placed at the center part of the entire drone. Now, what are the input and output of the flight controller? Why flight controller is actually what flight controller actually do? So it takes some input and generate the output, and the between part all the algorithms which is performed by the controller. So what are the inputs for the flight controller? These are the sensor values. And what are those values? These are like angular velocity, acceleration, orientation, position, which will be measured from different sensors. Then the only thing it do is output The output of the entire flight controller is fed to the motors through the ESC, which will control the thrust and torque. So this is the main purpose of the entire flight controller. Now, here you can see the entire block diagram, how the flight controller actually do and entire drone how operates. Like at the very beginning, we have the flight controller system. The flight controller system generates some output, which will fed to the actuator, which is the motor. And when motor rotates, it rotates the propeller. And when propeller rotates, it moves the drone. So here we have the feedback loop, which is the sensor. Because whenever the drone moves, the sensor will read the data, and this readed data again flash to the flight controller, which again measure the error, like what is the pilot requirement. If the drone is at the same position, then the drone will fly hourly. If there is any error, then control algorithm will try to solve this error, which will move the drone. So this is how the entire flight control system actually works. Now let's talk about the sensors. So in drones, there are multiple types of sensors used, like accelerometer, barometer, magnetometer, compass, color sensor, GPS, LiDAR, sonar sensor, temperature sensor. These are all sensors that can be used in a drones. But the specific sensor, without them, the drone will not fly. Are this one. The one is the accelerometer. So this is a device which actually measures the linear momentum of the drone in the all three axes. And how it does it measures. So there is a internal plate capacitance into the sensor. Whenever the sensor moves, the capacitance get changed. And due to this change in capacitance, the controller measures how much is the acceleration actually. So this is, and based on this, it produces some data, and with some specific protocol like I2C protocol or SPI protocol, we can communicate this sensor to the flight controller, which reads this acceleration data. So this is about the accelerometer. Now the next sensor, we have the gyroscope. What is a gyroscope? Gyroscope is a device which measures the angular rates of the device. So the best example is your mobile phone. When you rotate the mobile phone, the screen get auto rotates. Why? Because there is a sensor which measures the momentum of the device, and it figure out the device has tilted, so I have to tilt my screen as well. And similarly, in the drone, this sensor is present to measure the angular momentum of the drone, and then send this data to the flight controller. So this is the role of the gyroscope. Then we have the IMU, which stands for inertial measurement unit. So actually, IMU is nothing just a combination of accelerometer and gyroscope. Both sensor at a single chip, not individually, which will help us to save the cost as well as the space on the entire flight controller. So, and the best example of this sensor is MPU 6050. And probably in your BTEC project, you might use this sensor widely. Now, the next sensor is the barometer. What is barometer? So this is a sensor which actually read the atmospheric pressure. And why we need the atmospheric pressure data? Because based on this data, we can calculate the height of the drone, which is altitude of the drone. Because as we all know, when we move toward the Earth's surface to the space, there is a decrease in the air pressure. So every meter, there is a certain amount of pressure which is decreasing. So this sensor reads this pressure, then with some control algorithm, with the help of some formula, we convert this pressure data into altitude. Then this altitude data again fetch back to the flight controller system, which is the main controller. Then we have the GPS. GPS, as we all know, like global positioning system. What is the role of GPS? So GPS is directly communicate with satellites. Why? Because we need the specific position of the drone. I want to know where is my drone flying exactly. So how I get to know? With the help of GPS. GPS provide me latitude and longitude data of the drone. And based on this, I can implement multiple feature inside the drone. The very first thing is the position hold mode. Then I can have the geofencing. I can have the return to home mode, loiter mode, so many possibilities with just the help of a single GPS. Now, here at this chart, you can see how all electronics are connected together in a flight controller system with the flight control system. And all of this sensor and actuator and every component is placed at the fixed position onto the frame. Here you can see at the cube orange is the flight controller. Now at the top, you can see there are two here GPS, servo motors, I2C splitter, optical flow sensor. There is a here link receiver, camera, battery. Then we have the ESCs, we have the motors. This is the transmitter here link. So these are the majority of devices which is widely used in the assembly of the drones. So now let's have some research about what is the Indian drone market. This is the section 5 of our topic. So over the year, we have seen like in the our war situation as well, like India-Pakistan war, this is a Russia-Ukraine war, and different in our Operation Sindoor as well, how the drones are actually utilized to destroy the enemy. Okay, so in the late years like 2024, 2025, the drone market was about 0.45 billion dollars. Then in 2025, it is 0.47 billion dollar. But the prediction for 2030 is 1.39 billion dollar, because now we can see what is the actual use case of the drone. Every sector, the drone is very helpful, becoming very helpful. Like considering agriculture sector, defense sector, surveillance, everywhere the drone is become very widely used, and very it saves the cost and time. That's why. And these are actually the Indian drone companies who are actually building the drones in India. We consider like Idea Forge, Pila, Garuda Aerospace, Dronacharya, so Maru Drones. These are the companies who are developing the drones in India in different sector. Like for government, industrial application, these are the companies. For agriculture sector, logistics sector, manufacturer, software side. Yeah. Then these are some like component manufacturer companies, system integrators, service providers like Idea Forge, Garuda. Then component importers and distributor like Robo.in. You might heard about it, which is the variety of component which from which we order. So, what is the entire conclusion of today's session? So here, what we have learned today, like what is a drone and what are the various sector it is used. Then how the drones fly and hover and maneuver in the air. Then forces and moments involved in the movement of the drone. Then the next thing, like components that are used to build small drone and its assembly. The next thing is the flight control system and some sensors, how the sensor works, and some basic details about the Indian drone market and about the companies. So this is today we have covered the basics, introduction, some physics behind the drones. But this is not finished yet. Tomorrow we were going to see how the drone actually navigates in the air with the ground control station, how pilots command, how.
That is all for today. Make sure to subscribe. Click the ball for today. Click the button below. Make sure to subscribe. Click the button below.